Okay, so in the last video we talked about the first three rules of the the science game, of how scientists develop their ideas. They observe nature, they ask question about something they see that they don't understand, and then they come up with an explanation to explain what it was they saw. And the explanation has to be a scientific explanation, what's called a hypothesis. And that means that it can't invoke the supernatural. You can't use the supernatural as part of the explanation. And also that the explanation can be testable because it can be used to make predictions that you can see whether they come true or not. So that brings us to the fourth part of the process of science, which is making predictions based on the idea, on the hypothesis. And this is actually the most important part of the scientific method. You have to be able to make predictions based on whatever your explanation is for how nature works. And it's these predictions that are going to be used to determine whether your idea is a good one or not such a good one. Basically, a good scientific hypothesis is one that makes predictions that come true. And a bad scientific hypothesis is one that makes predictions that don't come true. So the way we make predictions is there's a certain way you say this. So you say, assuming my idea is correct, let's assume my hypothesis is correct. Then, based on that hypothesis, if I do this, I should see that. So I'm making a prediction, not about what I've already seen, but about what I will see if I do something, assuming my hypothesis is true. So, for example, let's take that sky-ocean hypothesis that we came up with. It said the sky looks blue because it's reflecting the color of the oceans. All right, so, wow. How can I make a prediction based on that idea? Well, here's how. Let's suppose we go to a planet where there are no oceans. A planet without oceans, without water. What will we predict based on our idea? What will we predict on that planet? We'll see if we look into the sky. Will it still be blue? So if the sky is really a reflection of what's on the planet, and we go to a planet without oceans, then we would predict that on that planet there would be a different color sky. We wouldn't actually see a blue sky. So that's a prediction that's based on the hypothesis. If we look at the sky on a planet with no oceans, then the sky on that planet will not appear blue. Now that's consistent with our hypothesis. Okay, now you might be thinking, well, we can't really do that. Well, actually, we've done it. In fact, we've done it a few times on different planets. So, for example, we've actually sent humans to the moon, and there are no oceans on the moon. And we haven't sent humans yet, but we've sent probes with cameras to Mars, to the surface of the planet Mars. And those cameras have taken pictures of the atmosphere of Mars. So, in fact, we have been to other planets and looked at the sky, either directly with our own eyes or remotely using cameras. And the other planets we've been to don't have oceans. So did the sky color change? Is the sky color different on the moon, for example, than it is on Earth? Is it different on Mars? The answer is yes. And for example, I can show you a picture. So this is a picture taken with a rover of the Martian sky. This is also the Martian desert. Actually, what amazed me when I saw these pictures the first time is how much the Martian desert actually looks like Earth deserts. This is, wouldn't be that unfamiliar a scene if you looked at it here on Earth. Now, Mars has no ocean. There is no ocean on Mars. There's no liquid water on the surface at all. And if you look at the color of the Martian sky here, you can see it ain't blue. So this would be what's called an experiment. An experiment is where you actually test the prediction. So first you make a prediction based on your hypothesis. My prediction is if we look at the sky on another planet with no oceans, it ain't going to look blue, based on my hypothesis. So that's the prediction. But we actually could test this prediction eventually by sending the experiment we did is we sent people or machines to other planets where there were no oceans, and we had them look at or photograph the sky. So that's the experiment. The experiments, when we talk about experiments in science, experiments are really just tests of predictions. They're ways of testing to see if predictions that we've made from hypotheses come true. So you can see here that my prediction that on a planet, say like Mars, the sky wouldn't look blue because Mars doesn't have oceans, it actually is true. If we take a picture of the Martian sky, it does not look blue. So this, what we would say is this experiment here, sending a probe to Mars, taking a picture of the sky, this experiment supports my hypothesis. That is, my hypothesis made a prediction, and that prediction came true in this one experiment. Now, does that mean that my idea is absolutely true and we don't have to look any further? And the answer is no. No, you can't just completely validate a scientific hypothesis based on it passing one predictive test. In order for scientific hypotheses to be really well accepted in science, they have to pass a whole lot of predictive tests. That is, you have to use them to make lots of different predictions and then see that all of the predictions come true, not just one. Sometimes with one you get lucky, but it isn't real. Now, if you do a lot of testing of a scientific hypothesis, and you use it to make a lot of different predictions, and they all come true, then you can publish your hypothesis in a scientific journal. Scientific journals are journals that pretty much are only read by professional scientists. It's how they communicate with each other to let each other know what they're doing, what their hypotheses are, how their tests have gone, which hypotheses seem solid based on testing. So it's really the way that scientists communicate with each other, primarily, is through these journals. Since there are scientists all over the world and they can't always meet face-to-face, they communicate with each other through journals. So usually a scientist will publish the hypothesis in a journal if their hypothesis has actually passed many predictive tests, not just one, but many different ones. Then they realize there might be some truth to it, and so they publish it. Now, if the hypothesis had failed the test, for example, let's suppose we'd gone to Mars and taken pictures of the Martian sky, and it was blue just like Earth, but there's no oceans at all on Mars. Well, that would actually indicate that my hypothesis was wrong, because it made a prediction that did not come true in that case. Now, of course, the prediction did come true in this case, but if it hadn't come true, if the sky on Mars had been blue or the moon sky had been blue, then we would have had to do what scientists have to do, which is that if their hypotheses fail their predictions, if they don't pass the predictive tests, then they have to change the hypothesis. That's an indication of the hypothesis that the idea was wrong. Because if ideas are wrong, then they make predictions that don't come true. If they're right, then they make predictions that do. What scientists are trying to get at here is the truth about nature, the true aspect of nature. And if you've found truth, then the predictions that you make from what you found will come true. If your idea is wrong, though, then at least some of them will not. So if your hypothesis is making a bunch of predictions that don't come true, that indicates a problem with the hypothesis. And now you've got to go back and change your idea. That's what you're required to do as a scientist. So these really, you can call this 5A and B if you want. These are the last steps of science. If you come up with an original idea to explain nature, if you do a lot of different predictive testing and it makes predictions, a bunch of different predictions that come true, you publish it so that other scientists can know what the idea was and do their own testing maybe. If your idea fails your tests, then usually you won't publish it. Instead, what you'll do is you'll go back and have to change the idea. You'll recognize that it's just not right. So that's the basic process of science. That's how scientific ideas are developed. And some of this may seem kind of complicated to you, but I'm going to, in the next video, we're going to go through a real world example of this, and I'm going to show you that you have actually done this and do it all the time. You just don't break it up in your head into these particular steps. But these actually are the steps you follow, the steps of observing, asking a question, coming up with an answer, making a prediction based on the answer, and then doing an experiment to test the prediction. You do that all the time. In fact, almost whenever you're confronted with something that you're trying to figure out and can't explain right away. So science is really just formalizing the way that humans think and do problem solving and just putting it into formal language. So again, in the next video, we're going to go through an actual real-world example of something you've done, I'm sure, many, many times in your life.